We spent 2,000 years building modern civilization. We figured out electricity, split the atom, put a man on the moon. And somewhere in all of that, we left the keys to the entire global economy in a 2-mile-wide hallway. This is the Strait of Hormuz, the world's most expensive design flaw. And right now, a group of engineers is drawing up a $100 billion plan to delete it. 20% of all the world's oil and liquid energy passes through the Strait of Hormuz every single day, no exceptions. Let that land for a second. 1 in every 5 barrels of oil on the entire planet squeezes through a choke point that at its narrowest is just 21 miles wide. But here is where it gets almost absurd. Ships cannot use the whole 21 miles. When you account for shallow water, reef systems, and the shipping lanes themselves, tankers are actually navigating a corridor closer to 2 miles wide. 2 miles. Some airport runways are longer than that. We are talking about 17 to 21 million barrels of oil moving through this gap every single day. That is enough energy to power Germany, France, and the UK simultaneously, all funneled through something the size of a small river. And sitting on either side of that river, some of the most consequential supply chain infrastructure on the planet. The oil fields of Saudi Arabia, the gas reserves of Qatar, the largest in the world, the production capacity of the UAE, Kuwait, and Iraq. All of it flows one way, through the Strait of Hormuz. Engineers have a term for this kind of problem. They call it a single point of failure. In software, a single point of failure means one component going down can crash the whole system. In infrastructure, it is a bridge with no bypass, a tunnel with no alternative route. The Strait of Hormuz is the ultimate single point of failure, except the system it supports is not an app or a building. It is the global economy. And for decades, the world just accepted this. We built trillion-dollar industries around it. We designed shipping fleets for it. We structured entire national economies to funnel through it. But now, something has changed. The tolerance for that kind of fragility is running out, and someone has decided to propose a fix so audacious, it sounds like science fiction. So what is the fix? The proposal on the table is this. You ignore the strait entirely. You go around it. But here is where it gets interesting. Going around does not mean finding a new sea route. It means carving one. The plan focuses on the Musandam Peninsula, a rugged, dramatic finger of land that juts down from Oman into the Persian Gulf. It is technically separated from the rest of Oman by a strip of UAE territory, which already makes it one of the more geographically strange places on the map. And sitting right behind it, blocking any shortcut to the Arabian Sea, the Hajar Mountain range rising to peaks of over 6,500 feet. The proposal is to blast a canal straight through those mountains, not around them, through them. A shipping corridor carved out of solid rock, connecting the Persian Gulf directly to the Gulf of Oman, completely bypassing the Strait of Hormuz. Now, before you compare this to the Panama Canal and think, okay, we have done this before, let me stop you right there, because that comparison is exactly the kind of thing that makes engineers uncomfortable. Panama Canal. Maximum elevation 26 meters. Dug through tropical jungle and soft volcanic soil. Took 10 years. Considered the greatest engineering feat of the 20th century. Musandam Canal. Maximum elevation roughly 2,000 meters. Cut through dense limestone and dolomite rock. Estimated timeline, unknown. Considered by some engineers to be virtually unprecedented. Panama was a jungle with a hill. Musandam is a vertical wall of rock. The Hajar Mountains are not soft earth, they are ancient, compressed limestone and dolomite, some of the hardest rock formations on the planet. Blasting through them is not a bigger version of digging a canal. It is an entirely different category of problem. To put the sheer scale into perspective, engineers estimate the project would require removing somewhere between 1.5 and 3 billion cubic meters of rock. That is not a typo. Billion. For context, the entire Panama Canal excavation removed roughly 200 million cubic meters, and that nearly broke the United States financially and took the lives of over 5,000 workers. The Musandam project would require removing up to 15 times that volume of material that is exponentially harder to cut through, and the canal itself cannot just be any width. To accommodate the supertankers, the VLCCs and ULCCs that carry the majority of the world's oil, the waterway needs to be deep enough and wide enough for vessels that are essentially floating skyscrapers. We are talking about ships that are 400 meters long and loaded with 2 million barrels of crude. This is not a project where you can cut corners on dimensions. The mountain does not negotiate. Here is where the story gets genuinely strange. Because a logical person looks at all of this and asks one simple question: why? Why would anyone spend $100 billion, a number larger than the entire annual GDP of countries like Hungary or Ecuador, to build a canal through an almost impossible mountain range? The answer, when you start peeling it back, is that the cost of not building it might actually be higher. Let us talk about what supply chain fragility actually costs. Every time the Strait of Hormuz experiences even a minor disruption, a technical incident, a vessel grounding, a period of heightened regional tension, global oil prices move, not a little. Significantly, in September 2019, drone strikes on Saudi Arabia's Abqaiq oil processing facility, the single largest disruption to global oil supply in history, caused Brent crude to spike nearly 15% in a single trading session. And here is what that attack actually revealed: one facility, one disruption, one day. And global energy markets nearly went into shock. Now imagine the strait itself going dark. That is trillions of dollars in economic exposure reacting to a 2-mile-wide geographic constraint. Now multiply that by every passing year. The world is not using less energy, it is demanding more. The countries that sit on the Gulf's reserves are exporting more volume, not less, as global demand continues climbing. Every year that the Hormuz bottleneck remains the only exit route, the systemic risk compounds. Insurance premiums for tankers navigating the strait have quietly been rising for years. Shipping companies build contingency costs into every voyage. Refineries in Asia and Europe carry larger strategic reserves specifically because of Hormuz uncertainty. The hidden cost of this single geographic design flaw runs into hundreds of billions of dollars annually when you total all the downstream effects. So a $100 billion canal starts to sound different when you frame it not as a construction project, but as a 100-year insurance policy. The UAE and Oman, the two nations whose territory is most relevant to this project, have both been studying alternatives to Hormuz dependency for years. The UAE completed the Abu Dhabi crude oil pipeline in 2012, a $4.2 billion overland pipeline which, by the way, already came in nearly $1 billion over its original estimate, that can move 1.5 million barrels per day from the interior fields to Fujairah, bypassing the strait entirely. It was a massive achievement, and it moves about 8% of what flows through Hormuz on a peak day. That is the scale of the challenge. Even a $4 billion pipeline barely scratches the surface. A Musandam canal, in theory, could move the other 92%. It could transform Fujairah, already one of the world's busiest bunkering ports, into the new logistical center of global energy. The UAE has been systematically building the infrastructure around that vision for years. Deep water terminals, storage facilities, refinery capacity. The canal would be the final, audacious piece of that puzzle. But here is the number that makes even the most ambitious engineers pause. $100 billion is the low-end estimate. Mega projects at this scale routinely exceed initial budgets by 50 to 200%. Oxford University analyzed 16,000 major infrastructure projects and found that 9 out of 10 come in over budget. The Channel Tunnel went nearly 80% over budget, nearly doubling its original cost estimate. The Sydney Opera House came in at 14 times its original budget. And the Berlin-Brandenburg Airport, a relatively modest project compared to a mountain canal, opened nearly a decade late. A canal through the Hajar Mountains has never been attempted. There is no comparable project to baseline the cost against. No contingency fund covers. We hit an unexpected geological formation at 1,800 meters. The real bill for this project could easily reach $200 or $300 billion before the first tanker passes through. Even if this canal gets built, you have just built another bottleneck. Think about what a canal through a mountain range actually looks like in practice. It is not a wide open sea route. It is a narrow, constrained corridor, possibly no wider than 300 to 500 meters at its navigable center, carved through solid rock. The mountain walls on either side are not going anywhere. The passage cannot be easily widened once built. And the moment this canal becomes the primary alternative to Hormuz, every vessel that currently transits Hormuz starts asking whether it should transit here instead. We would essentially be solving the problem of one narrow passage by constructing a second narrow passage. The geography changes, the dependency does not. This is the central paradox of the entire project. The Strait of Hormuz is dangerous because the world is dependent on it. Build a canal to reduce that dependency, and the canal itself immediately becomes something the world is dependent on. Supply chains do not distribute risk just because you add an alternative route. they often concentrate it in new ways, especially when the alternative is also constrained by geography. There is a concept in logistics called the Braess Paradox, the counterintuitive idea that adding capacity to a network can sometimes make the overall system perform worse, not better. When you add one alternative route to a heavily trafficked choke point, you do not necessarily split the traffic evenly, you often just shift the pressure. The old bottleneck does not disappear, it gets a companion bottleneck. And suddenly, you have two narrow passages to worry about instead of one. Smart infrastructure planners have been wrestling with this for decades. The solution is almost never build one alternative. It is build several. Pipeline networks, overland rail, distributed port systems, strategic storage facilities spread across multiple regions. The countries that understand this, Japan, South Korea, Germany, have been quietly building diversified energy supply chains for years, reducing their Hormuz exposure not with a single mega project, but with dozens of smaller, complementary ones. The canal proposal is spectacular. It is the kind of project that gets on the front page, that becomes a symbol of engineering, ambition, and national vision. But the unglamorous truth is that a $10 billion distributed pipeline network might do more for supply chain resilience than a $100 billion mountain canal, and it would do it faster, with fewer unknowns, and with a much cleaner risk profile. So why is the canal getting so much attention? Because in geopolitics, as in architecture, sometimes the statement matters as much as the solution. Here is what we actually know. The Strait of Hormuz is real. The fragility is real. The economic exposure worth trillions of dollars annually is real. And the pressure to find a solution is growing every single year as energy demand climbs and supply chain resilience becomes a strategic priority for every major economy on the planet. The Musandam Canal may never get built, but the fact that it is being seriously proposed at all tells you something profound about where we are. The world's most powerful economies, nations with essentially unlimited construction budgets, are sitting around a table looking at a 2-mile-wide stretch of water and asking themselves a question that should have been answered a century ago. How did we let this happen? And the answer might be even more uncomfortable than the price tag. Because the Strait of Hormuz is not the only geographic choke point holding the global economy hostage. There are 6 others. The Strait of Malacca, the Suez Canal, the Panama Canal, the Bab el-Mandeb, the Turkish Straits, the Danish Straits, each one a single point of failure, each one carrying a piece of civilization on its shoulders, and almost none of them have a credible bypass plan. So the real question is not whether we can afford to build a canal through the Hajar Mountains. The real question is, can we afford not to rethink all of them? Next up, the Philippines. Just bet $8 billion on connecting 7,000 islands into one nation. No country has ever tried this. Find out if it works, links right above you.